consider this language 0 power n, 1 power m, and m is between n and 2 power n. Let's check whether things like this can be accepted by PDA or not, push down automaton or not. So we know the extreme cases we have seen. If it is n, yes, there exists an automaton. If it is 2n, yes. Now it is in between, which means if you look at the sample strings, 0, 1 is valid, 0, 1, 1 is valid. For 0, 0, it is 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 4 ones. Correct? So number of ones is between n and 2n. So this is valid. Now how do we model this? So let's look at say 0, 0. In this case, you see that this one, this 0, this 0, this one. But when you have something like this, we saw that this 0 corresponds to these two. You can pair these ones and associate with 1, 0. But when it is something like this, interestingly, one can associate 2 ones for this, just 1, 1 for this. Or it is other way. For this one you associate 2 ones, for this one it is this. Suppose the input is say 000 111, then you associate exactly 1, 1 for each 0. Suppose the input is like this, then maybe this 0 I associate 2 ones, this one 1, 1, this one 1, 1. Or for the same thing, you can also do this. For this one you associate 2 ones, for these two it is 1, 1. Which means in some sense we can check whether this one, the number of ones is between n and 2 power n. And so these examples kind of telling you that one has to map some pair of ones to 0 and rest of them there will be just one match, meaning 0 corresponds to 1. Let's look at this input. There are 5 ones, up to 6 is allowed. Now if you simply associate 1, 1 for each 0, then we will be left with couple of ones. We can't check whether it is in the form 0 power n, 1 power m, where m is between these two. So we have to somehow come up with the scheme and associating either a 1, just a single 1 with a 0, or pair of ones with 0, so that when you reach this, input tape is empty and the stack is also empty. Now for this, what I do, for this 0 I associate this pair, and for this 0 I associate this pair. For this one it is just 1, 1. Or you can also do like this. For this one you associate this one, for these two, these pairs. Now in some sense I have to guess, or the machine has to see, for this 0 should I associate a single 1 or 2 ones. Remember, machine cannot count and tell you there are 3 zeros, there are 5 ones. The machine is designed in such a way that it can read exactly one symbol and push a symbol or more than one symbols onto the stack. And for example, the earlier one we saw that it was pushing two symbols onto the stack. So the scheme is designed in such way that when we exhaust the input, the stack is made empty and we say it is a valid input. Or if one of them is non-empty and we say it is rejected, it is invalid input. So this kind of association is something we have to model carefully when we design these kind of automatons. Okay, so let's see. Having given this, now you see that the machine has to take a call. Should I associate a pair or should I associate just a single one? How will automaton think of whether it should go for two ones or just one one? Okay, and there are many possibilities. And automaton can think of this scheme, thinking that let's associate 1 1 for this 0, later 2 ones, or maybe 2 ones now, later 1 1. So some kind of guessing is happening. Should I go for this or this? So that brings non-determinism. So the automaton we look for, because it has to do this guessing, what we design will be non-deterministic push down automaton. It is NPDA. So far, whatever we have designed for 0 power n, 1 power n, 0 power n, 2 power n, they are all deterministic PDAs. It was pretty clear that 0 corresponds to 1 or 0 corresponds to 2 ones at every stage. So 0 power n, 1 power n, 0 power n, 2 power n, both are deterministic PDAs. For this one, it was clear that 0 must be mapped to 1 at each iteration. And for this, it was clear that 0 must be mapped to 2 ones at each iteration. But for this, you see that for some zeros, it is a pair of ones. For some, it is exactly 1 1. So which one should be mapped to a pair of ones or which one should be mapped to just 1 1, that is not clear. That's kind of uncertain. So the uncertainty is precisely non-determinism. Formally, when you say it is non-determinism, so that brings non-deterministic PDA into the discussion. And most importantly, you see that for all these inputs, now you look at one more, say 4 zeros followed by something like this. Now I can associate a pair of ones for this and a pair of ones for this, then maybe 1 1 for this. Or you can also do this way. You may associate 1, then you may associate a pair, then you may associate 1, then you may associate a pair. So the mission kind of has to go through this uncertainty for all inputs at each iteration, which means asking for a deterministic PDA. So DPDA for L is not possible. So because this guessing or non-determinism is kind of inherent. So one cannot avoid this non-determinism. So this tells you something important. So there are languages like 0 power n, 1 power m, and m is between this. No DPDA exists And what is possible is only NPDA exists, which means the class of languages accepted by non-deterministic PDA is a superset of strict superset of class of languages accepted by deterministic PDA. There are languages, they are not equivalent. Given this, can I come up with an equivalent DPDA? Answer is no. Okay. For example, here is a language for which NPDA exists, but there is no DPDA. Okay. So please note, for finite automaton, NFA and DFA, they are equivalent in terms of language acceptance. For PDA, NPDA is not equivalent to DPDA, meaning the class of languages accepted by this and this are not. For some of them, given NPDA, you can find an equivalent DPDA. Not for all. Here is one example. Here is an example for which you see that NPDA exists but no DPDA. So that tells you that this set is a strict superset. There are languages which are here but not here. And every deterministic PDA is also a non-deterministic PDA. Which means when you are at a state, say Q0, on reading a 0, you are guessing, should I map it to 1, 1 or should I map it to 2 1s? So delta of Q0 comma 0, you have more than one transition. When we formally describe, you will have more than one transition. Should I go for this configuration or should I go for this configuration? And so naturally that brings non-determinism. Now we will formally describe this using transition function. There you see that delta of say Q0 comma 0, you have more than one configuration, or you may go to more than one configuration for the next iteration. Fine, which we shall see next.